All right, let's tackle this new question here, my party people, and it begins with the end. We're going to begin at the end here where it says, how many square feet of pavers are needed? All right, so immediately, you may not think anything of it. Most people here will just focus on the word how many feet, but it's actually not going to be what you want to focus on. You want to focus on two words here, and it's going to be square feet. My party people who have been to classes like this before, when we mention square units, square feet, square centimeters, square miles, square kilometers, we are talking about area. That's what it is. So here what we're talking about, how much area of pavement or pavers are needed. Before we continue, everybody who's watching, even if you're frantically taking notes, does that make sense? Again, they say square feet, and what we are being told to find via square feet is the area, and specifically how much area for the pavers. So let's now take a look at the information and see how we're going to get the area, but specifically, be careful, only for the pavers. Here we go. A rectangular patio is 18 feet by 14 feet. So let's draw that out here. Here's my rectangular patio. Booyah right there. So I have 18 feet by 14 feet. Perfecto. And then what I am going to do here, it says, but a 10 by 6 foot section is reserved for a fire pit and will not be paved. Okay, everybody, so if the fire pit is not supposed to be paved, so let's draw the fire pit right over here. If we have our fire pit right here in the middle and it's not supposed to be paved, are we going to include the area of the fire pit? Are we supposed to include that area of the fire pit? No. No. For the fire pit, let's just write this here. Here's the fire pit. We will not include. Do not include. Again, the reason, sorry for that overflow, anybody with OCD, I apologize, but specifically it's mentioned right here. The fire pit will not be paved. So what I want to do then is I only want this area here. This is all I want. I do not want that. So what I'm going to do is I'm going to find the area of my patio, which is 14 times 18, and then I'm going to subtract the fire pit. That's the big game plan. Find the big area and take out what we don't need, which is the fire pit's area. So let's go ahead and do that. I'm going to move everything over here ever so slightly, perhaps make things a little smaller. And now let's get to work. The area of the patio is going to be 18 times 14. We can go ahead and try to do that in our heads. 180 plus, what is that going to be, 72? So it's going to be 252 if I have that correct in my head. But I'll go ahead and just double check just in case. 18 times 14. 8 times 4 is 32. Then 1 times 4 is 4. Carry the 3 is 7. Next up, we have 8 times 1. 1 times 8. Add these together. And then we have 2, 15, and 2. So yes, 252 was it. So we have 252 for the area of the patio. And now that was step 1. So now we'll do step 2. And we'll find the area of the fire pit. Because once we have the area of the fire pit, subtract it. We'll take it away because it's not supposed to be included. So the area of the pit is going to be 10 times 6, which is going to be pretty straightforward. Just going to be 60. And now the last thing we need to do here is subtract. Don't get confused. Don't get tricked. Yeah, we see 252 right there. But no, we are not done because we wanted to take the difference of the areas. And that's going to be step 3. 252 minus 60 gives us 192 square feet. And that's what makes the correct answer here. Answer choice D. And there we go. Bingo. All good. Let's get started on this next one here. And as always, everyone, we are going to read the question sentence first. So here it says, how far did she climb during the first 5 hours. All right, everyone. So before we even get started, it's very clear here that the problem says, how far did we climb during the first 5 hours? Not after the fact, not before that point, but during the first 5 hours. Everyone, do we all see that? Yes or no? Before I get started on actually pointing out the solution. Cool. So if at this point you've tried the problem out and me just reading this question sentence gives you some sort of epiphany, good. Feel free, change your answer. It's a little too late, but I think you might notice that this problem says that we start here at negative 85 feet. That doesn't matter. Then it says she climbs upward an unknown distance. Oh, that's the distance we're trying to find because it's 65 feet per hour for 5 hours. That's what we care about. One more time, everybody, look. It says, how far did she climb during the first 5 hours? So there it is right there. The distance that we'll climb in that 5-hour period is going to be equal to the rate times the time. And the rate that we're given is 65 feet per hour. So there we are. 65 times 5 is going to provide us with the correct answer. And so upon doing that here, 65 times 5, 5 times 5 is 25, carry the 2. And then 6 times 5 is 30, carry the 2 is 32. So there it is, super straightforward. 325 feet is the distance that was climbed, which is pretty funny given that we have all of these pieces of information that really don't mean anything at all. So there we are, everybody. Again, this is one of those exercises where, hey, your eyes aren't trying to deceive you. We're telling you to find this thing, and it's listed right there. So there we are, and we'll see you in the next one, everybody. All right, next question. Question reads, 7x equals 4x plus 9.6. All right, so we have a decimal here. We're solving an equation. I can definitely feel the anxiety in the room, but we're going to handle this one step at a time. We have variables on both sides. So my first goal is really going to be, let me clean this up. Let me get the variables on the same side. And to be honest, I have two options. One option is I can move this 7x over to the right side. Here's my little imaginary line. I can take this 7x, move it over to the right side. But if I do that, we would have to move the 9.6 over there, and then we still have to divide, and that's a lot of work. So here's what I'm going to suggest instead. I'm going to suggest that instead of moving the 7x to the right, let's start with the 4x and move it to the left. Watch what happens. Not only do I get the variables on the same side, but I keep the coefficient, that number in front of the x, I'm going to keep it positive. And I think you guys like that. I think we all like dealing with positive numbers. Check this out. Minus 4x cancels out on the right side. And then we have 7x minus 4x giving us 3x. On the right side, we still have that 9.6 right there. But boom, there we go. We've taken one step and we've made this a much more manageable problem. Now that we're here, my friends, the last step is what on both sides? That's right. We're going to divide by 3 on both sides. Nice and easy. So check this out. We'll have 3 like that. Cancels out. And so we'll have 3 going into 9.6. For those of you wondering if we're supposed to use the decimal rule and move decimals over, not necessary because we're dividing by a whole number. Remember, the goal is to divide by a whole number to make your life easy. And once we do it, 3 goes into 9 3 times. We'll put that decimal right where it was. And then we ask ourselves, how many times does 3 go into 6? And that will be 2. And there we go. It's a whole 6, nice and easy. Boom. And the correct answer for this problem here is answer choice A, 3.2.